Hi Bobcats. In this video we're going to look at some qualitative analysis schemes. There are ways that we can selectively precipitate ions so that we can identify what metal ions are present in a solution. So our objectives are to identify ways that we could selectively precipitate some ionic compounds and also apply that concept to identify metals that are present in a sample. That is a component of the 1142 lab. There'll be some qualitative analysis labs where you'll work on identifying what metals are present in an unknown. So one of the standard general chemistry labs is to give students a solution that contains a mixture of metal ions, and you have to identify which metal ions are present in that solution. And this qualitative analysis scheme shown in this flow chart is one way that that can be done. So you start up at the top with that mixture of cations, and you add a source of chloride ion, such as HCl. Now the H does some things too because precipitation is a little different at low pHs versus high pHs, so generally this scheme will work best to start off at low pHs. And out of the entire list of metals that you might be analyzing for, only a very small number of metals will actually precipitate with chloride. Silver, lead, and mercury can precipitate with chloride. And so if you take your sample and you add some HCl to it and nothing happens, then you know you don't have silver, lead, or mercury. But if a precipitate forms, then you've got a little bit more work to do because you have to follow some additional steps to see which one of those three is present. So then you can take what we call the supernatant liquid. The supernatant is the liquid that is above a precipitate that has formed, and it might have some ions remaining. What you'll do next is keep it in acidic conditions and add sulfide ions. And if any of this long list of metals is present, they'll precipitate out. And then there's a whole bunch of steps that you go through to try to separate those ions from each other. And then for anything that was left in your supernatant, you try adding some more H2S, but then making the conditions basic. And at basic pHs, you get a whole bunch of other stuff precipitating out. And then finally, you're going to add a carbonate ion or phosphate ion and try to precipitate out a bunch of other metals. And then there are some cations that will just stay in solution, and we have to do something else like a flame test to identify that those ions are present. So a scheme like this can take weeks to carry out in a general chemistry lab, especially if you have one sample that you carry out this entire analysis on. I'd say that each row in this flow chart is 1 week of work, at least, in a general chemistry lab. So a while back, our Gen Chem 2 lab spent about half the semester doing qualitative analysis like this. It's kind of fun. It's like a great big puzzle, trying to figure out what's present in solution. But the curriculum's changed a little bit. Now we typically only spend about 2 weeks on qualitative analysis.